Okay, chapter 3.4 is on writing proportions. Remember, proportions is a way that we compare two things. Um, Sometimes they want us to use a table, or sometimes we have a table, and it's a great way to use to write proportions. I have a chef who's increasing his recipe. He needs more, and I don't know what his recipe is, but it includes black beans and tomatoes, and it could be chili or something like that. What's important is that he knows that he wants to make a larger batch, so he goes from 1.5 cups of black beans to 6 cups of black beans. And he goes from one tomato to some other number of tomatoes, and he wants to make sure that there's as many tomatoes per cup of beans as there were tomatoes per 1.5 cup of beans in the first recipe. So he just kind of writes it out as a proportion: 1.5 cups of beans per one tomato. How does that compare to if he has 6 cups of beans? To X tomatoes. So if you can see that our table actually mirrors our proportions. Now these look like fractions, but it kind of looks exactly the same that we had in the table. Our cups of beans are on top and our tomatoes are on the bottom. And we know that there's more beans than tomatoes as far as units go. And so we're probably going to have, I would guess 4 cups of beans here, but we still have to kind of do the math. We can use cross products, or we could figure out how many times 1.5 goes into 6. And cross products is probably easier. So we multiply 1 times 6, and we set that equal to 1.5 times x. And that is the same as 6 is 1.5x. That's 1 times 6 just simplifies to 6. And then we divide both sides by 1.5 to get the x by itself. And it could be that you want to use a calculator for that, which for me means going up here. We're going to do 6 divided by 1.5 because that's the fractional form. 6 divided by 1.5 is 4. Aha, I knew it. Now how do I get that to go away? Oh, there we go. So that is equal to 4. So 4 is equal to x because we simplified by dividing both sides by 1.5. So that means 4 cups of tomatoes. Or not 4 cups of tomatoes, 4 whole tomatoes. Okay, now let's look for a second at this fraction. Just for fun, just to think about a different way to do it. 6 over 1.5 is the same. If we double it, we can do this in our head. It's the same as 12 over 3. So if we did 12 over 3 and we doubled this one, that would be... Oh, we don't have to double it. We can just simplify it because that's what we were trying to do over here. We used a calculator, right? To do 6 divided by 1.5. Huh, I got myself confused for a second. Now we're taking 6 over 1.5. We're trying to simplify it, but instead of using a calculator, we want to use regular math. So we multiply them both by 2, just because I know that 1.5 times 2 is 3. And I want to get numbers I can work with. And then 12 divided by 3, or 12 thirds, is equal to 4. So we can get 4 this way, or we can get 4 using a calculator. And of course, I always prefer that you find a method to do it without a calculator because that requires your brain to do some cool things. Sometimes mental math works for solving proportions. Example 2 talks about 3 halves. I think I want to get a darker color. We keep using these bright colors and it seems like they're hard to see. 3 halves is x over 8. Of course, you have better vision than me, so you probably can do it. This is mental math, and we want to think, well, how many times does 2 go into 8? Well, 4. 2 times 4 is 8. Well, then 3 ought to go into 6 the same, or the x the same amount of times. So if I multiply it by 4, I get 3 times 4 And so then x is equal to 12. That's pretty easy. Now, if you look at this is a proportion, but in a lot of ways it's the same as writing equivalent fractions. 3/2 times 4/4 is equal to 12/8. And they are equal to each other, and that's how we know what the x is. There's another example. 5/8 is equal to 15 over d. It doesn't matter where the x is. The x could actually be in any one of these four places, or the d. This time it's a d. 5 goes into 15 3 times, so 8 times 3 is going to be 24, so it's going to be 15/24, or d is equal to 24. Pretty cool. Even if you do it the other way around, where the x is on this side, say we have something like that, you can say 5 divided by 5 is 1. If you want to go this way, 5 divided by 5 is 1, so something x divided by 5 is going to be 2, and that'd be 10. Or you can go backwards, because going backwards is just multiplying. 1 times 5 is 5, so 2 times 5 is 10, going the other direction. Hope that makes sense. That should help you get your lesson going. All right.